All right, we are about 2 minutes past the hour, so we'll go ahead and get the show on the road. For those of you joining us, all participants will be muted until the end of this presentation. If you do have questions throughout, feel free to put your questions within the chat. We will be answering questions at the end, so if you want to hold your question until the end, that's totally fine too. Once we do open it up for people to ask questions, you can either raise your hand or type it in chat, and we'll let everybody, you'll be able to unmute yourself and ask your question at that point. For also another reminder for those of you who have joined us before and for anybody new to these webinars, once this webinar is complete, we will go ahead and post this onto our YouTube and we'll send a recap email out along with the presentation so you have a copy of it as well. And again, if there are any questions throughout the presentation, go ahead and type those in chat. And without further ado, I'll turn it over to Kelsey and Mike to get started.
Good morning, everybody. Thanks for joining. My name is Kelsey Gormley. I'm the VP of our grid integration team here at GridSME. And with me, I've got Mike McElhany. He's one of our senior principal consultants. So we're going to talk today about Appendix H of the LGIA and how that gets translated into CAISO's documentation in the NRI process. So we are going to be focusing on CAISO today. So if you're here to ask about ERCOT, NOGR questions, we might have some time at the end to dive a little bit into that. But just so everybody's aware, we're going to focus in on CAISO for this webinar. We did want to start off with a quick safety minute. So Sarah, I actually am going to turn it back over to you for that to talk about hearing.
Yeah, so our quick safety minute for today is just hearing protection. October is National Hearing Protection Month. So for those of you who travel out to job sites, especially if you're going to a conventional generator, make sure that you either have hearing protection with you or that you get your hearing protection at the job site. There are some specific decibel ranges for your hearing protection that you want to make sure that you're adhering to. OSHA has very great guidance if you wanted to look that up online. We don't have that here on this slide, but happy to follow up with anyone if you've got questions later. But the main thing is making sure you've got either the hearing protection that you can put directly in your ears, or you can get ear muffs. There's a whole bunch of different types of hearing protection. So with that, pass it back over to Kelsey.
Sarah. Okay, so like I mentioned today, we're going to have sorry, I don't know my screen keeps bouncing me around. So we are going to be talking about Appendix H of the CAISO LGIA. And just so everybody's aware, we do have quite a bit of content today. So Mike and I are going to be tag teaming this. I'll spend the first half just focusing on what exactly is in the Appendix H of the LGIA. And then Mike is going to talk about how those requirements are represented later on in the NRI process, specifically in bucket 3. So we'll dive right in. All right. So first off, we're going to just do a quick overview of Appendix H. Then we're going to talk about Appendix H and NRI. We're going to go into each of the different sections of Appendix H, talk about how that data is reported both in the Attachment A workbook that is submitted in bucket 3, as well as the inverter settings report that is submitted in order to substantiate the documentation and the inputs that we're putting into the Attachment A. And then hopefully at the very end, we'll have some time for all of your questions. We know this is a very hot topic for a lot of our clients, so we will hopefully have some time set aside for questions. But if we don't get to it, please feel free to email us as well. Mike and I will be sharing our contact information if folks want to follow up with questions as well. Okay, so what is Appendix H? Well, in very, very plain terms, Appendix H is the technical rule book for connecting solar PV plants, battery energy storage systems, and hybrids to the CAISO grid. Today, we're going to go through what Appendix H requires and, importantly, why those requirements exist. These rules were really put in place to ensure that all of these IBR inverter-based resources are operating reliably and supporting the grid, rather than creating additional risk in grid reliability issues. So we want all of these wonderful new resources to come online, but we want them to be good grid citizens. So what does that mean, and how are we enforcing that? So why was Appendix H created in the first place? Well, it was actually the result of some very specific events. The 2016 Blue Cut fire disturbance occurred when there were many PV units that were tripped offline. And the goal, again, of Appendix H is to prevent IBRs from adversely impacting grid reliability. So over the next few slides, I'm going to explain a little bit about each of the key requirements that are represented in Appendix H, including ride-through capacity, reactive support, talk about relevant standards such as NERC's PRC 24 for ride-through, and then also highlight how that applies to IBRs. IBRs, for the purposes of this, right now, PV BESS hybrid projects. By the end, you'll see how Appendix H turns these resources into reliable resources that actually stabilize the grid and support grid reliability to keep our power system working smoothly. So CAISO's tariff Appendix H specifies interconnection requirements for all inverter-based generating resources. To achieve commercial operation through CAISO's NRI New Resource Implementation process, developers must demonstrate compliance with each of the Appendix H requirements prior to synchronizing to the grid. And again, my favorite topic is definitions. So sync, the definition of sync in this context is you will be moving from not utilizing grid power to commission your facility to moving into what most people would refer to as the test energy phase. You are using grid power, submitting test energy schedules to CAISO, and you are either putting electrons onto the grid or pulling electrons off the grid if you're a storage facility. So for the purposes of this conversation, pre-sync means you have to have all of this documentation in and accepted by CAISO prior to putting any electrons on the grid or taking them off the grid, if that makes any sense to everybody. So this happens in typically bucket 3 of 6 in the NRI process. And Michael is actually going to be talking through some of the specifics in the Attachment A workbook and identifying the sections that directly relate to Appendix H. He's also going to show you some generic inverter settings reports that we submit along with that Attachment A, Attachment A submittal. And we're going to identify which of those values are related to the requirements in Appendix H. So lots of appendices and attachments in this conversation. It can get a little bit confusing. So I'll level set for a second. Appendix H lives in your interconnection agreement. The Attachment A is typically submitted as part of your initial interconnection request, but it's also resubmitted in bucket 3 of the NRI process. So those are the documents that we're talking about. All right, so again, not to reiterate myself too much here, but Appendix H was created to ensure that all new inverter-based generators meet additional performance and data sharing standards beyond just the basic interconnection requirements. CAISO introduced this appendix specifically to tackle the unique attributes and behaviors of inverter-based resources such as PV and batteries, and to prevent those issues from causing large-scale grid disturbances. The focus is on making sure that these resources can ride through grid disturbances, provide voltage support, and not adversely affect stability from day one. Appendix H fills that gap by spelling out exactly what an IBR plant must be capable of before it can interconnect. So in terms of the scope, Appendix H applies to all inverter-based generating facilities connecting to the CAISO grid. That means large-scale solar farms, wind plants, standalone batteries, hybrid solar and storage projects, they all fall under these rules. So if you're bringing on a new PV or BESS project into the CAISO, you will be required to apply with Appendix H. It is technology neutral. It doesn't matter if it's PV or storage. The performance expectations are very comparable for all the fuel types that I just listed. So the idea is to treat inverter-based resources as, first-class generating units that are subject to reliability standards similar to other conventional generators, but tailored to the specific power electronics nature of these resources. So this way, as California's grid becomes increasingly dominated and relying upon these inverter-based resources, we maintain that consistent reliability baseline. Reliability is key. If you talk to anybody at the CAISO these days, that is their favorite buzzword. So that's really, really what we're looking for when we're reviewing this documentation. Appendix H requirements are initially implemented in the NRI process. Again, so that is what Mike's going to talk about in bucket 3. There's also a post-COD modeling requirement as well that will reiterate, what is being represented in your Attachment A documentation and make sure that the resource is actually performing to those standards. So we'll go through into some of the specific sections of Appendix H. It can get a little bit techy, so if I'm talking over your head, I apologize. Just for everybody's awareness, this recording will be, like Sarah mentioned, it will be provided to everybody as well as the presentation. So you will have the presentation to go back and review if you'd like to spend some more time on a particular area of interest. So the first is voltage ride-through capability. So for a normally cleared 3-phase fault at the point of interconnection lasting roughly between 4 to 9 cycles, where the PV voltage drops to near zero, the asynchronous generating facility must stay online throughout the fault as well as the subsequent recovery. And similarly, for a single-phase fault with delayed clearing, such as like a backup protection clearing of a breaker failure, the facility must also ride through the low voltage period until the fault is cleared, even if that fault persists longer than a normal clearance. So in practical terms, there is no tripping allowed for any common grid fault cleared within normal protection times. This is to avoid widespread generation loss and impacts to the grid. Appendix H explicitly disallows ceasing current injection for under voltage conditions. The inverters must stay electrically connected and actively support the grid during this dip. Momentary cessation is only permitted for extreme overvoltage events above 1.20 pu, and that's just as a protective measure. The reactive current must be proportional to the voltage drop and delivering full available reactive output when the voltage is 0.5 pu or below. On the other hand, for transient overvoltage conditions, inverters must remain online and absorb reactive power. So that means they're producing negative VARs potentially to help bring that voltage back down. This behavior is known as dynamic VAR injection absorption, is analogous to a traditional generator's exciter response, and is crucial for stabilizing voltage during faults. In addition, Appendix H does mandate rapid ramp up of inverters, which should restore the output at a rate of at least 100% of capacity per second, achieving the full pre-fault output at less than 1 second after voltage is back to normal. So that's that fast response component of this. So even if the inverter is momentarily reduced output or has ceased current for a high voltage transient, it must come back online within 1 second. This fast recovery ensures, again, that the grid does not experience a prolonged generation shortfall once that fault has been cleared. So we'll move on into the next section here on if an inverter does trip for, again, more voltage ride through, it is required to attempt to resynchronize and reconnect to the grid within 2.5 seconds of that trip. The only exception is if the trip was caused by a hardware or internal failure, like a fatal fault, in which case immediate reconnection might not be possible. This requirement does ensure that transient trips are not permanent and that the resource should come back and support the grid as soon as it is safely available to do so. Inverter control systems must tolerate a brief loss of synchronization with the grid without tripping. If the grid voltage phase reference is lost or slips, the inverter's PLL should freeze at the last known phase angle and continue injecting current at that phase for up to 150 milliseconds while the inverter's attempts to relock to the grid. So they're not allowed to trip or stop output purely due to a short loss of sync. They have to ride through these events as well. Appendix H requires that plant controllers be programmed to allow the inverters to promptly be resynchronized and ramp up power immediately following that fault clearance. Only after the inverters have resumed normal output should that plant controller resume its higher level control actions. And this does help to ensure that ride through and rapid recovery behavior mandated by Appendix H is not overridden by a slower plant level control scheme. So Appendix H, you got to hit it no matter what your plant controller is doing. All right. So reactive power and power factor, that's the next section we'll talk about in Appendix H. Most of you guys are familiar with this. This is actually also represented in your LGIA. So inverter-based generation facilities, they have to have the capability to operate across a power factor range of 0.95 leading to 0.95 lagging. And that is measured at the high voltage side of the main step-up transformer. So in very basic terms, the plant should be able to both supply reactive power leading and absorb reactive power lagging up to roughly 33% of its real power capacity to support grid voltage as needed. So this reactive capability can be achieved through the inverter's controls or additional VAR support equipment. Modern inverters are designed to provide reactive power within that range. However, if they don't, the interconnection may require installing supplementary devices such as, a shunt cap bank, reactors, things like that to meet that VAR range. Any solution or combination is acceptable as long as it achieves the required reactive power and is agreed upon by the PTO, the participating transmission owner, and CAISO. So reactive power is always in, and that equipment should always be in service. The interconnection customer is not allowed to disable or switch off the reactive support. They have to stay online. All right, we'll talk a little bit about SCADA capability and power system stabilizers. So an asynchronous generating facility needs to provide supervisory control and data acquisition, SCADA, capability to transmit data and receive instructions from the PTO and CAISO to protect system reliability. With CAISO, that's the CAISO rig, and with the utility, that's typically via the RTU. So the participating transmission owner and CAISO and the asynchronous generating facility shall determine what SCADA information is essential for the proposed asynchronous generating facility, taking into account the size of the plant and its characteristics, location, importance in maintaining generation resource adequacy, and transmission system reliability. So this can be specific to your interconnection. This isn't just a generic out of the box. This can be specific to your interconnection as well. No power system stabilizer devices are required because the inverter and plant controller can inherently provide fast voltage control. Dedicated power system stabilizer hardware is not required for inverter-based facilities. Traditional power system stabilizer devices are generally associated with synchronous machines. In inverter-based resources, the function is essentially replaced by the inverter's controls and fast reacting power electronics. So CAISO does not mandate a power system stabilizer on asynchronous generation as long as the plant overall can meet the dynamic performance criteria in other ways. Okay, I had a brief moment here where we're going to talk a little bit about I think this is my last slide, which is transient data recording. So this is where most folks get tripped up with Appendix H, which is this requirement at the plant level as well as the inverter level for transient data recording, very fast transient data recording. So each recording will include, as a minimum, 150 milliseconds of data prior to the triggering event and 1,000 milliseconds of data after the event. That data has to be stored for a minimum of 30 days, and it needs to be produced at CAISO's request. So this is typically what we see as a big concern for most of our facilities is how do we meet that timestamp requirement? If we've got a bunch of inverters, they're all trying to come back online at the same time. Is our network properly sized to be able to meet that requirement in the event of a fault where every piece of equipment is trying to come back online at the same time? So one of the things that I think Mike will dive into a little bit is the difference, between the different time sequencing capabilities. So there's precision time protocol and there's NTP. So both of those are options. However, NTP typically is not fast enough to be able to meet this requirement in our experience. So there are a lot of other options that are being explored out there by the different inverter manufacturers. IRIG-B is another option that has been put forth by a few of them. But this is really, I think, the main crux of where we run into issues with compliance on Appendix H is, can all of these devices at both the plant level and the inverter level meet this requirement? So I'll let Mike speak to that a little bit more. But for now, I'm going to hand it over to him to talk about the bucket 3 documentation that we submit that reflects how a resource is going to meet the Appendix H requirements. So Mike, back to you.
All right. Well, one of the things we want to start off with is, GridSMEs, grid integration project managers, really work collaboratively with the resource owner and the inverter manufacturer, and I work with them on the submittal of the documents that need to go in for the bucket 3 submittal. So go to the next slide, Kelsey. So kind of as a lead into this section, I just want to let you know that GridSME has had significant interaction with all of these inverter manufacturers. 2023, I did 25% of all the facilities that submitted information for the inadvertent tripping NERC alert. 2024, we did even more, almost doubled the number of plants that we did for the modeling deficiencies NERC alert. So we've worked with all of them, and that's how I kind of became the inverter guy for GridSME. But I've got contacts at each one of these inverter manufacturers, work with them very closely whenever we run into something new with CAISO, and we move from there. And so one of my roles is when bucket 3, when the plant gets to bucket 3, and we need to have the control protection settings reviewed by CAISO, as well as the attachment A and the inverter settings report, that's when I get involved. We get a lot of information from our inverter manufacturers. I've got 4 of them that have provided me in the last week some additional information that's going to be content for this particular presentation as well. So into the next one, each inverter manufacturer has their own mechanism to obtain initial inverter setting requirements from their client. And this is one of the themes that you'll hear throughout this part of the presentation is attachment A is attachment A is attachment A, no matter who the inverter manufacturer is. But the inverter settings reports and the settings themselves within inverters are wildly different between inverter and manufacturer to inverter manufacturer, and sometimes even on from Gen 2 to Gen 3 to Gen 4 inverters, there's how it does something and how you set it up to do that thing is different. And so each of the manufacturers has some sort of a process that may include forms to be filled out by the client. The client might be the EPC on behalf of the generating owner developer. It might be the geo developer themselves. Some of them have ad hoc processes. We've worked with one that's fairly new to CAISO. They really don't have a form. They just have conversations, and they're really working on maturing that form, and we're working with them to help make that happen. So I mentioned that it's important to note that the inverter manufacturers provide these forms to their clients. We've got projects where the GridSME client is working directly with one inverter manufacturer on the settings, but they're working through another entity, either an O&M provider, battery owner, or battery entity who's not the inverter manufacturer, to work with the inverter manufacturer. So we need to really work closely with our clients to get as early in the process as we can to understand who their inverter manufacturer is, what the model is, so that we can help with the formulation of the inverter settings forms that need to be submitted to the inverter manufacturers. This is very critical for fault ride-through requirements, whether it's PRC 24, IEEE 1547, or 2800. And again, if it was ERCOT, it might be the NOGR requirements. How that particular inverter is set up to disable momentary cessation and anti-islanding is very different between inverter manufacturer to inverter manufacturer. And then queue priority, reactive capability priority and thresholds, and then the K factor, which we'll go into in a lot more detail. So my goal is always to help clients achieve a one and done getting through CAISO when you get to bucket 3. I'll let you know if we ever achieve that, because there's always something, it's always some little nuance, but we try to get it as close as possible so that the turnaround, once, CAISO provides comments back, as soon as we get those, we're addressing them. But our goal is to save time on the bucket 3 reviews and the attachment A reviews so that we can get through the process quickly. This screen is just some examples of what the forms are that we get from the inverter manufacturers. So I've got the example of a Tesla one. You can see that there's, it's hard to read it. I guess it's a little bit too small, but there's K factor and the deadband associated with, what these recommended settings are versus what you want to really put in there. The SMA settings, here's fault ride through to be activated. How do you, their mode is for full, that's full reactive capability. That's the one we want to go with for CAISO. So I just kind of pulled that piece of it out. For Sungrow, they're asking, okay, well, what are your requirements for fault ride through? Is it PRC 24? Is it IEEE 1547 or 2800? And then that will help, dictate moving on. Power Electronics has a Google form, and in PDF form, it's 28 pages. So it's a little bit too big to try to fit on a screen here. So I did make that complete attempt. And as I mentioned, some entities don't have a form to give you. They will just have conversations, and GridSME is always willing to be involved in those conversations so that we hit the mark from starting from day one. So kind of tying back to Kelsey's part of the presentation on what the bucket 3 or what the attached Appendix H requires to how you actually prove that. It's really through the NRI, the New Resource Implementation process, and there's the control protection. So the control protection for the relay settings. I'm not going to spend any slides on that particular piece. That is a piece that I and other engineers will look through to make sure that the settings for the particular voltage and frequency tripping do not, violate PRC 24 or the other fault ride through components. But the main focus is going to be on the control protection inverter settings report and the attachment A, the full. That's why we always get confused on saying attachment versus appendix, because it's attachment A to Appendix 1. And here we are today talking about Appendix H. I do just have a little screenshot of RIMS, the Resource Integration Management System. That's where we end up putting all of these documents for the 6-bucket process with the California ISO NRI process. Just trying to get as many visual things as opposed to just a bunch of words on these screens. This is from the NRI implementation resource guide. It again mirrors what you heard from Kelsey in terms of the Appendix H requirements, but these are the kind of things that we go through, and I'll go through additional slides to provide more specific examples and details. This is the attachment A project configuration tab compressed down. I just wanted to get it all so that it's all available in one spot. There's 1 through 10 sections of the attachment A project configuration work tab. All the ones that are in green are going to have to be filled out for all inverter-based resources. The 2 red ones will never have to be filled out for the inverter-based resources. And section 6 is only required, it's in yellow just to set a separate color, is required to be filled out for BESS systems, whether it's hybrid, DC coupled, not DC coupled, or standalone BESS systems. That section needs to be filled out. I'm going to be focusing on section 5, section V, because that's where we see most of the bucket 3 issues. And so first thing off the top is it's very important that everyone be aware that section V applies to individual inverter data. We've had projects that we had to kick back because they came in with values that were representative of the entire plant. 43 inverters, and so we see an MVA or other ratings that are well beyond an individual inverter themselves. So this section, and as you get into the questions, you can lose that fact because it might be a question that, oh, they're asking for this, and so you answer in a particular way. We have to make sure that this is strictly to the capability and settings associated with the individual inverters themselves. So the next one is not a bucket or is not an Appendix H specific, but I always like to pull this one out because it can be a gotcha. There's a couple of gotchas that happen here. The top left screen, top left part of the screen demonstrates, the answer was no, but the right-hand one was the short circuit data tables. And for line to line and single line to ground faults, there's 0.3, 0.6 per unit negative sequence current. And so how do we say no? And this is actually a Tesla inverter. And we've gone back to Tesla and they confirmed that they do produce the negative sequence current. You should never have negative sequence current on a balanced three-phase fault. But for line to line and single line, if there is typically more than about 0.2 per unit negative sequence current, CAISO may ask the question, which again, causes a delay. So we try to do a confirmation, whether it's a new inverter manufacturer, we get that confirmation. And it's a difficult answer because of the way the workbook is constructed. Does the inverter produce negative sequence fault current? No, under a balanced three-phase fault, but yes, under another fault condition. So how do you answer the question? Yes and no. And when you answer yes, then you have to fill out the following V.9.1 through .6 that contains this additional information. And then if you do say yes, then CAISO wants to know, well, what's the prioritization of negative sequence versus positive sequence current? So it's a big can of worms, but we've been working with the inverter manufacturers to kind of get this down. We've been working with the California ISO. One thing to note was through our efforts, California ISO actually became aware that PG&E was starting to require negative sequence current being enabled in inverters, and yet CAISO has never studied it. So just something to be aware of, that there's some additional nuances that we keep tracking with the inverter manufacturers, the clients, and PTOs and CAISO specifically. All right, so now kind of getting into more of the meat of it. One of the questions at V.10 is, will the inverter go into momentary cessation? As you heard from Kelsey, one of the requirements of Appendix H is that momentary cessation is not allowed. It's allowed in very, very rare conditions, only on over voltage conditions, but it's generally not allowed. CAISO has prohibited it under most conditions. So how do we determine that? And again, I showed you the slide of 12 different inverter manufacturers. Every one of them is different. The example I'm showing here, in their inverter settings report, they have this top red box: momentary cessation can be disabled if you set the ride-through and trip curves to the identical values. So on the left, you have the ride-through in terms of when it's going to ride through, and then the trip side, and you have to understand there is a frequency component and a voltage component, but these tables, and I only showed the frequency and I should have showed the voltage as well. But as long as everything in the left-hand table matches everything in the right-hand table, that means that momentary cessation is disabled. Another inverter manufacturer has two flags that LVRT, low voltage ride-through, high voltage ride-through, and you either enable or disable those. And if you disable those, that disables momentary cessation. And yet when CAISO initially saw that, they're like, well, then you don't have low voltage ride through enabled, and you have to have that enabled. And so we had to go back work with the inverter manufacturer and CAISO to make the understanding and the link that was their mechanism to disable momentary cessation. So it's, again, every inverter manufacturer, and for us to get involved as soon as we can, early as we can, to make sure if it happens to be a new model that we've not dealt with, we have to make sure that we get that information on any differences, nuances, settings that may affect any settings that we go along. We have so many projects that we've worked on, whether it's the NERC alerts or whether it's grid integration, NRI, and other interconnections, that a couple of my inverter manufacturers, not only being on speed dial, but they've actually given me access to their entire SharePoint. So I have access to their documents. I don't get an update on when something new has been put in there, so I'm always having to continually mine it. But it's just something, again, that we're really trying to stay on top of. V.16, this one shows 16, 17, and 18 because they're all in one little section. If you don't do if momentary cessation is disabled, then you have to answer these questions. But the first one, describe the inverter control during system fault conditions. Provide information regarding control freeze, priority, blah, blah, blah. And then there's this little parenthetical K factor. We're going to go through a couple of slides to talk about the K factor and what that really means. But this particular one is one that, if it is not done correctly, both in the inverter settings report and the attachment A workbook, it will get kicked back by CAISO. So on this next slide, don't want to get into too much math, but I've got the formula here. But K factor is really a slope that once you get outside the allowable range of 0.9 per unit to 1.1 per unit voltage, you need to start injecting the reactive current properly. And you have to achieve the full reactive capability at 0.5 per unit voltage or below. So you see on this chart, there's a dashed line through the middle where the power plant controller is controlling, power priority, and there's reactive based on power factor and everything else. But once you get outside or below, we'll specifically talk about that. Once you get below 0.9 per unit, you need to start moving and injecting proportionally, which is what it says in Appendix H, once you get to the 0.5, where you've hit the full reactive capability of the plant. So it's simple terms, it's basically a slope. The one gotcha that we came across with and working very closely with Tesla on several projects was, oh, by the way, their inverter actually is capable of greater than 1.0 per unit current injection. And CAISO's model is completely based upon a 1.0 maximum current injection. And because the Tesla inverters have the capability of injecting greater than 1.0, it changed the slope in order to, once you start injecting at proportionally injecting at 0.9 per unit, going down to the 0.5 or below, you had to have a different slope. And so we actually have a different slope for Tesla. And I just, again, want to quickly, there is no requirement for a K factor of 2. And a lot of times you'll hear that statement that CAISO requires a K factor of 2. That is not correct. It is, you have to have full reactive capability injected at 0.5 per unit voltage, which means if you have 1.0 per unit current injection, it will be a slope of 2 in order to achieve that. But there is nowhere in Appendix H in your LGIA that it says you have to have a K factor of 2. So this is kind of the background for that. The next slide, just a couple of examples on how you determine whether a particular inverter has anti-islanding disabled. In this particular one, in the blue box on the bottom, it's got anti-islanding with a 0. That means it's disabled. Momentary cessation has got a 0. That's disabled. Other inverter manufacturers, you have to disable frequency anti-islanding and voltage anti-islanding separately. So again, every inverter manufacturer is different once we get into there. But there is a question that says, is anti-islanding disabled or not in attachment A, which is neutral to whoever the inverter manufacturer is, but we have to also make sure that the settings document, the inverter settings report has the same thing. And in this particular one, this is a Tesla example. It's showing a K factor, a positive K factor, a negative K factor of 3. That again then needs to line up with V.16 within the attachment A workbook. Yeah, I'm not going to slow down. So we're now getting into a couple of them that, does the inverter lock itself out after a certain number of certain numbers of tripping during a given time period? There's really no good way to answer this question within the attachment A workbook. So what we've been getting back from CAISO and what we have confirmed with them is they are looking for all of the reasons that the inverter could trip. So it might be a sensor failure, it might be loss of voltage, it might, there's all sorts of things. And we typically will work with them to either include that in the inverter settings report with here's the list, whether or not it requires, it can be automatically recovered, or whether it requires manual intervention. Sometimes we end up providing CAISO with a manual. Here's the technical manual, here's all the errors, here's the ones that are, critical faults that would require manual intervention and so on. But that's one of the things. So, the question, the space to put the answer does not afford that. And it is typically then a separate document that is provided to CAISO in order to do that. And then once tripped, what is the ramp rate in percentage per second? The CAISO Appendix H requirement is 100% per second. And we've had, some where we catch it where it says 100% per minute, or some other number that isn't 100% per second. That is a hard and fast, and that's where that ends up coming into play. And then there's inverter settings, other documentation that can show that as well. The next slide is just another one that we double check because it's exposed. The inverter settings report has both frequency and voltage tripping settings, but attachment A only has a place in this V.19 where you can put the frequency tripping settings. And so we really try to double check this against the inverter settings report to make sure that the numbers line up. But we also do a quick first cut, not necessarily in engineering all the way to the point of interconnection, but we validate this against the no trip zone associated with PRC 24 today. So just wanted to show that one real quickly. And then there's a couple of orphans, and it was near the end of Kelsey's part of the presentation where she talked about the GPS clock time syncing to 1 millisecond, and that you have to have data sampling for every 10 milliseconds. There's no place to put this in the attachment A workbook. It's not historically been addressed in the inverter settings report. There might be in an inverter settings report where it makes a reference to network time protocol, but it doesn't give any sort of capability of the inverters to be time synced at 1 millisecond and actually collect the data, sample the data every 10 milliseconds. So again, working with CAISO, we can either get this through an attestation, like some inverters, like SMA does. They have a to whom it may concern. These inverters have the capability to meet the Appendix H requirements for time syncing and for data sampling, or we can get additional information, upload that into RIMS at the bucket 3 timeframe to provide the CAISO review to have that. Because if they don't get that confirmation, they will kick it back. And every time, I'm not trying to throw them under the bus, but it's, every time they have any little thing that we have to respond to, that resets their clock for when they're going to finalize their review. So even if we turn it around in one day, it might be another 2 weeks to 4 weeks before we get the approval at the bucket 3 level. And again, I just call this, both the GPS time syncing and the data collection as orphans, because there really isn't any place to put that information within the attachment A workbook. That's where the orphans and historically the inverter manufacturers have not included that as part of their inverter attachment report. So just kind of final thing is pretty much as anything is fodder for CAISO comment. or follow-up question. We recently had one get kicked back because they needed to know the number of inverters per feeder collector. And we've never had that one before. You know, there is a requirement to identify the number of inverters, but we've never had it at that level of granularity. So we're always playing catch up with, you know, their requirements. We do try to push back and try to, you know, where are you getting that requirement from, to make sure that we're not inventing new things that we have to follow. Because we've had things that have been approved 2 years ago that aren't getting approved a year ago, stuff that was approved a year ago, 6 months ago that isn't getting approved today. So we're constantly working with them on that. You know, and again, inverter reports are different from inverter manufacturer to inverter manufacturer. And, you know, even within the inverter manufacturer, depending on who the engineer is, I've got several different inverter manufacturers where I get different looking inverter reports depending on who's the project engineer for the inverter. You know, GridSME is constantly working with the inverter manufacturers and CAISO to help and ensure a smooth and successful bucket 3 review. And that kind of leads into the next slide, which is just kind of a plug for tomorrow. There will be the NRI CAISO New Resource Implementation Forum. And I just put that into the chat so that you have the actual links that are on the slide here. If you want to register that, if you happen to be local in Folsom or in Sacramento, you could attend in person. So, you know, just copy and paste the information I put into the chat so that you can do that. You can join by a web call, or you can join by phone only. It is from 8:30 to 12:30. Again, another opportunity to hear, you know, CAISO side of the story, and maybe get hear some questions that come from people, you know, throughout the process. So I think that's the last slide, and we can go to questions. Hopefully, we've left enough room for that, even though I talked 155 miles an hour.
No, it was great. Thanks, Mike.
One minor thing, Mike, on the timing of when I'm going to preview something that they're going to announce tomorrow at that forum, that CAISO's previously stated turnaround time for reviews of bucket 3 documentation was 10 to 15 business days. They're officially moving that out to 30 business days, and that will be communicated out tomorrow. So again, more support for Mike's thorough review and early involvement on these. If you're working with GridSME, and if you're not and you'd like to, please reach out because we would love to add to our collection of, you know, different projects. It only makes us better when we have all of that data set, you know, from other projects as well. So yeah, that's my last plug, and we'll jump into questions, Sarah.
Awesome. Yeah, and just a reminder for everyone, I'm going to go ahead and unmute all participants, but if you could keep yourself muted if you're not speaking, that would be great, just to cut down on background noise. So we did have some questions come through during the presentation. We'll get through those first. If anyone has a question that you want to follow up on, go ahead and type those in chat, or you can raise your hand, and we will try to get through as many as we can in the next 10 minutes. So the first question was from Jerry. And I don't know, Jerry, if you're still here and you want to unmute yourself and you can ask your question, or I'm happy to read it off for you as well.
I'm still here, thank you. I just want to understand at a high level whether these Appendix H performance criteria differ from NERC IBR requirements. So if inverters selected to meet NERC IBR requirements should be able to meet Appendix H almost by definition.
So there's all sorts of components to that question. The answer, I'll say, for specifically for PRC 29 fault ride-through components, the Appendix H actually says the current or any future version. So that one does open up a little bit of can of worms for the replacement for asynchronous fault ride-through with PRC 29 that is coming in the future. Appendix H will, at some point in time when PRC 29 is the official standard, they will be switching to that. Now, that doesn't change anything in Appendix H, but it can change things on the inverters themselves. And that's why when I showed the slide about, you know, whether it's PRC 24, IEEE 1547, or 2800, when you get into 2800, you're really getting into the PRC 29 world. And so really most all of the inverter manufacturers don't have a problem. There's been some ERCOT NOGR related ride-through things that have come into play. The one big difference that CAISO is actually significantly more stringent on is the time syncing and the data sampling. So once we get to PRC 28, the data sampling requirements there are not as stringent as the California ISO. But like a lot of things, when California ISO and California goes in a particular direction, the inverter manufacturers move in that same direction as well. So I don't think it's a huge, it might be, you definitely don't want to go back to a version 2 or a generation 2 inverter, but as long as you're at a generation 3 or 4, you should be fine with all of the current and future collateral components of Appendix H.
Great, thanks, Mike. Jerry, did you have any follow-up for that question, or hopefully Mike answered it?
Yes, he did. Thank you very much.
Great. All right, we'll move down to the question from Carlos, and I think Carlos did drop off,
Sorry,
so I'll go ahead.
To interrupt, I just had a question, an add-on question to the last topic.
Oh, sure. Go ahead.
On the CAISO's requirements for, the time data, do they test it or commission it in any way, or is it more like just a requirement that's trust but verify when the time comes kind of thing?
I was going to say, Kelsey, a year ago at RE Plus in Anaheim, I introduced Kelsey to several of my inverter manufacturers, and that was one of the questions, because there really isn't a place where it gets tested. And we've asked them, is there a way that you can lab test this, commission test this, and provide it? And the answer was no. So what we're left with is when a client gets a deficiency because there was an event and they weren't able to produce the information, especially specific to the 1 millisecond time sync and the 10 millisecond data sampling. So we've been working with them. We're not getting much headway, but there is no explicit requirement to test it today.
There's no really good way to test it, right? Like, I mean, what you test in the lab is not going to accurately reflect what happens in the field during a fault, right? So I mean, in all fairness, it's not really an easy test to commission or to administer during commissioning, because it's not just the inverters that have to meet this time sync requirement. It's the inverters on a network with all the other devices as well, that the inverter manufacturers don't really have control over. So it's something that's challenging for sure.
Yeah. So the inverter manufacturers, like I showed to whom it may concern, attestation from SMA, they basically say the inverter has the capability of sampling at these rates and being time synced at this resolution. It's really up to the network time protocol, and other things that are outside of their control. But this has been sufficient for getting through bucket 3, as long as we have the inverter manufacturer's attestation to the capability of the inverter itself. That's as far as we've had to go today with CAISO for bucket 3 approval.
And it has to be down to the inverter level. It can't be like a data concentrator.
Yeah, this is specific to inverter by inverter by inverter. And so,
okay. Yeah, thank you.
Again, depending on how the configuration of the network on site is, again, one of the very complex pieces is when you have a battery manufacturer that is not the inverter manufacturer for those batteries. Now you have another component of conflict on the battery management system and the battery software itself versus the inverter. The inverters have created another potential place for confusion. So when I talk to inverter manufacturers, I'm only asking them to provide or attest to the capability of the inverters themselves. What's outside of their control, they cannot make an attestation to.
Thank you.
All right, great. I know we do have a few more questions. We'll try to get this done within the next few minutes because I know we're running up against the time limit. But from Carlos, who I believe dropped off the call, he had a question early in the presentation. With these changes in mind, is the impact only to Appendix A, or will there be additional changes to the performance analysis for dynamic, steady state, and EMT models?
So Kelsey's smiling because when I put together a deep dive on Appendix H, I was talking about EMT modeling and a lot of other things. There are other things that are happening within NERC that may drive us to a world of EMT modeling. In some of my conversations with inverter manufacturers, if we could provide an EMT model, PSCAD model, they could turn the inverter settings around immediately because it is a direct one-for-one correlation with the inverter settings. From a PSCAD model for an SMA inverter or a power electronics inverter, it's a one-for-one. So we haven't started having the conversations with clients yet, but eventually you do have to provide EMT models. It might be something to be thinking about earlier in the process because it might also help out the inverter settings from a bucket 3 perspective if we were to do that. So I don't know, since he's not on, I'm not sure what the additional changes that he was referring to other than in the way I answered the question.
Yeah, and for those of you who ask a question, if you do have to drop off before we answer it, we will try to follow up directly with you, which leads to the next question. And I think Kyle also had to drop off, but this came from Kyle. It is clear that Appendix H compliance is required prior to sync when talking about new resources. Can you talk about Appendix H compliance timeline for existing generators? Second part is what might be required in terms of new changes to legacy inverters, and is it possible the inverters are not able to comply? And I know some of that you've covered already, but if you could summarize that, that would be great.
Muted.
Say, so
Oh,
right
no,
now,
you're fine.
Okay, let's say right now, legacy sites are not impacted unless you're going through changes to your interconnection agreement. So if you're planning on, say, repowering a facility, an existing facility, obviously that, those new generation pieces of equipment are going to have to meet the Appendix H requirements. But right now there is no requirement to go backwards if you're already a COD facility, unless you're changing your interconnection agreement and trying to, replace equipment.
Great. All right. And then Rawad, I know you had a follow-up question earlier, but you did ask a question in chat. Would you like to re-ask that, or did that get answered for you already?
No, I'd love to ask it. One thing that my ears perked up when you mentioned the negative sequence fault current yes/no scenario and some of the distinction there and the hiccups. I was wondering if you could go back to that slide and we could just say that back to me one more time.
Yeah, so we've had it on occasion where CAISO will say, well, you said no, and yet there's greater than 0.2 per unit negative sequence current. And that's how we found this Tesla one. So we said no, and CAISO questioned it. We went back to Tesla and they said, well, yes, it does. And, they provided the V.9.1 through V.9.6, answers that are required if you do say yes. So every time we see a no with significant, semi-significant negative sequence fault current for line to line or single line to ground faults, we have the conversation. If it's the same model we've already answered, we just get a confirmation. If it's a model that we haven't gotten the confirmation on, we confirm with the inverter manufacturer. Yeah, this is a lab that said, it had this, but under a normal condition, we're still saying no. SMA is, well, you can't answer the question yes and no. So, let's say no for, balanced three-phase faults and see what CAISO says. And so far, they've allowed that. And then, just the issue that in some cases, PG&E is starting to require that inverters that can enable negative sequence current, fault current, to do so when you're interconnecting with them as the PTO.
Okay, thank you. Because I did pose that question to Tesla and got an interesting answer of just no. And so I guess I was like,
How long
wait a
ago?
minute.
How long ago?
2 weeks ago.
Really?
So maybe it was
That's
just,
interesting.
maybe it wasn't clear. So
Yeah.
I made
Well,
sure to,
again, we worked with the same engineer on multiple projects and had a K factor of 2. And then all of a sudden he said, we need to have a call because we can't do a K factor of 2 because our inverters
Mhm.
actually inject 1.2 per unit current. And so, we had those, so we had, again, multiple clients that achieved bucket 3 approval with a no, and now we're saying yes. Same kind of a scenario where, when we brought this on a particular project, they came back and said, well, actually, yes, the answer is yes.
yeah, I guess it's one of those things that even happens on the CAISO side, right? Or depending on the reviewer you get,
Yep.
things might come up. So, all right, thank you.
Great questions. All right, we did have another question from Sean Rossetti, and I see, Sean, you are still here. Would you like to ask your question, or I can ask it for you? All right, I'm not seeing you come off mute, so I'll go ahead and ask it. And there are no silly questions, so I won't say that part, but is there a study requirement for the IVRs?
So again, within the LGIA, the process of interconnection, there are a lot of studies, not directly specific to Appendix H. But again, when you submit early on, you're going to need to be able to provide some power flow modeling information as well as dynamic modeling information. So there is a part of the interconnection process will require study requirements, but not the focus of today's presentation.
Great, thanks, Mike. And Nikki, I know you had a question in chat. Would you like to unmute and ask your question? And if not, I'm more than happy to ask it. So I'll go ahead. Are the IBRs required to be time synced to all other IBRs on site within 1 millisecond? Or is it okay for each IBR to time sync directly with a GPS satellite clock?
So that's an age-old issue that for sequence of events, if you do not have simultaneous time sync to all of your devices that are then recording information, how do you put together what happened first? And so the short answer is yes. And that's one of the reasons that there is some concern that network time protocol does not have the guarantee of that, as opposed to precision time protocol or direct injection of time sync into an inverter specifically, like through a direct IRIG-B interconnection. But the answer is that's the point of it, because otherwise you have a bunch of data that said what an inverter did, which inverter did it first. You'd have no idea if you have no understanding of the simultaneous time sync relative inverter to inverter.
Great, thanks, Mike. All right, and that concludes all of the questions in chat. I would like to open it up for any final questions. If you'd like to unmute or raise your hand, now is the time. And we'll give you a little bit of time for that. While people are mustering up the courage to ask your question, I will just say we will go ahead and post this recording to our YouTube, and I will also email all of the participants with a link to that, as well as a link to the PowerPoint that was presented today. If there are any other follow-up questions, maybe you think of it later after this webinar is over, feel free to shoot an email over to us. We're happy to answer that. I see Larry, you have your hand up, so go ahead, and if you've got your question, go ahead.
Hey guys, this is Larry Bourne, Range Power, and question was, I think, directed towards Michael. I think you mentioned something about that you guys like to work early with your clients when it comes to models for IBR resources. How early do you guys recommend, considering with new CAISO's process, that interconnection customers get started on their models before they enter the queue?
Well, on the models themselves, my point was more specific to as soon as you know who your inverter manufacturer is, we want to know so that we can start going, okay, well, it's SMA. These are our main issues that we need to get resolved with SMA. If it's sun grow, then these are different issues. The modeling itself that I was mentioning about doing earlier would be a way to really bypass the forms that you submit to the inverter manufacturer for how you want the settings to be done. Because if you have the EMT PSCAD modeling completed, you just give them that and they're good to go. And so, it's an evolution. And I think, we'll work on a case by case basis with entities that have they come to NRI for the grid integration team for the NRI six bucket process, but they also come to engineering at GridSME to do studies. Well, if we can dovetail one or two of those to prove out, the value of it, now we can share with all of our other clients what the ROI of doing it early is.
And I'll just add, just from a timing perspective, this attachment A document is submitted usually as part of your initial interconnection request package. And then it's requested again in the NRI process because CAISO recognized that a lot of times what ends up being built, specified from an equipment purchasing perspective, by the time you're ready to actually build the project, may be different from what was originally approved in your interconnection request. So this is kind of their opportunity to true that up. So my team would be looking, this is a question we're going to be asking in all of our kickoff calls with new clients, is who'd you spec for inverters, so that we can start having those conversations in bucket one or even before of the NRI process, and make sure that we are getting, Mike plugged in to provide input. So yeah, we recognize that could change. It changes all the time. So
Thank you. No, I really appreciate those answers. Thank you.
Yeah,
Thank you
and
both.
sorry, if you don't mind me going just a little bit longer, we can absolutely help leading into interconnection requests. So we can start as early as possible. Mike mentioned kind of at the very preliminary modeling before it's even necessarily a project that's in line. We can absolutely start kind of developing those PSLF, PSSE, PSCAD models.
Great. Thank you, Ryan.
Yeah.
Thanks, everyone.
Great. Well, I'm not seeing any other hands up or any other questions in the chat, so we'll go ahead and conclude this webinar. And like I said, we'll be sure to share this recording as well as the presentation with the team. And we really appreciate everybody joining us and hope you have a great rest of your day. Thanks, everyone.
Bye, all.